Good morning. Welcome to our webinar, How to Automate Your Server Configuration with SaltStack. My name is Fabrice Mule. I'm an IT consultant with ATEX for 4 years now, and mainly I work with server automation, starting with normal deployment, release management, but last but not least, config management. So let's talk a bit about automation. For that, let's have a look in our data centers in general. So, in the data center, there are several levels on which your infrastructure can be optimized, and there are plenty of places where ATEX can support you. One possibility is, for example, running a container infrastructure, for example, Red Hat OpenShift, Rancher, Docker, or Kubernetes. Normal server automation. So one of our tools in that case would be Ocarino, where we just map the lifecycle of a server, starting with deployment, configuration, and release management. But today's topic mainly is talking about config management, and we also support the usage of plain config management, in that case, Puppet, SaltStack, and Ansible, where our today's focus will be on SaltStack. So let's start asking the first question. Why do we need to automate at all? So going back to the early 70s and the first days of Unix machines, so how did computers look like there? So you had in general one or very few, very, very big computers filling out a whole room, the whole data center. So in that time, things had to be done manually. So you wrote your code, you applied it on your server, and so on. So this was quite easy. So it was not a big issue. There was no need for automation. But with time, the amount of computers get higher, computers got faster and smaller, and starting with a couple of dozen computers, hundreds of computers, and today it's quite common that data centers can run up to several thousand computers. And if you try to do that manually, it's quite some work. So suppose you have 10 machines you have to configure. So if you have to do it one by one, you log into any of them, install some packages, make sure that file configurations are right, you adjust some services. So if you do it for every single machine independently, this is taking some time. And after some time, repeating all your steps, you might make some sloppy mistakes, and then you end up with 10 identical machines, and the 11th is slightly different because you made a typo. So automation, first of all, it speeds up your deployments and your configurations. It increases stability because you avoid mistakes, because your configuration is written down. And this way you also achieve reproducibility. So in case you need to deploy the same configuration onto servers sometime later, in a month, in a year from now, you can just apply the configuration that you already wrote down and deployed on your servers today. And this easily allows you to orchestrate your services. But now let's have a look on what configuration management actually is. So here I borrowed some definition from Wikipedia. So let's see what Wikipedia tells us about configuration management. Configuration management is a systems engineering process for establishing and maintaining consistency of product performance, functional and physical attributes with its requirements, design, and operational information through its life. So basically with config management, you define how your system is supposed to look like, how it performs, and how you can design it and actually apply it. Config management applied over the life cycle of system provides visibility and control of its performance, functional and physical attributes. Config management verifies that a system performs as intended and is identified and documented in sufficient detail to support its projected life cycle. So you don't only deploy your configuration onto your servers with config management, but you document it, and actually you can cross-check. You see if everything works fine. In case of failure, will be notified, and you know something went wrong, and you can fix that. So configuration management follows the idea of infrastructure as code. So this means your configuration will be written down in code lines and can be applied to your servers. So in case of SaltStack, basically your code will be written down in YAML files. In addition, you can provide some digital templates if you need to deploy certain files. With config management, you do not only automate your systems, you also standardize them, because you create your standard configuration and you can actually create several environments for servers which have to be slightly differently configured. And in this way, when you need to you change the configuration of a certain amount of hosts, you can just edit your configuration and redeploy any of them, and then it will be fixed. So this is quite easy. Then you just edit it once and you deploy it on several servers simultaneously, and everything is fine. And all of this enables you to have a more efficient server management. So let's have a look on the history of configuration management tools. So one of the first config management tools, if not the first at all, was CF Engine, which was developed by Mark Burgess in 1993, based on C. And their idea was we needed to automate the management of a small group of workstations in the Department of Theoretical Physics. And originally, we were using shell scripts to do that, and we're configuring the servers with that. The problem was that we had different operating systems, different systems at all, and the shell scripts were not portable. So we needed to be adjusted for different kinds of systems. So we needed to create an abstraction layer on top of that. So that was CF Engine. So we could actually define the configuration and apply them on all systems independently of their architecture. CF Engine was or is agent-driven, so it means you have a central configuration server, and on your clients you have an agent checking for that, and it uses the approach of declarative language. So for those of you who are not familiar with the term declarative language, it's basically the contrast to imperative language, so the standard program language which I used before, so like Fortran, like C, like C++. Imperative language tells the computer what it actually has to do. You explain step by step how to achieve that. Do that, do step B, do step C, and so on. In contrast to that, declarative language does not the computer tell what it should do, but you declare a state. So you tell the computer, I want my machine in the end to be in that state. So I don't tell it how I get there, I just tell it I want to get there. And then the config management tool then knows what to do and actually applies the configuration. This leads to idempotence. So idempotence is a term from mathematics. It means if you apply a function several times on one state, it won't change anymore once the state has been achieved. So it means the first time I apply my configuration and my server is not configured yet, it will edit the configuration and change it. Once it's already in target state, repeating the config management run, it won't do anything because everything is fine. It will recognize I don't have to do anything because I'm already on my target state, and it will be happy. A few years later, Luke Canis developed Puppet based on Ruby. So similar as CF Engine, Puppet is agent-driven, so you have a Puppet master and you have a Puppet agent running on your clients. And it also uses declarative language, in that case, Puppet DSL. So let's have a look on a different approach, which appeared in 2012. Michael DeHaan developed Ansible based on Python. Python is not an agent-driven system. So agent-driven systems was just pulling the configuration from a central server. Ansible pushes the configuration by SSH. So you have one server which has the configuration stored in YAML files and Jinja templates and so on. And by SSH, you push the configuration to any server you would like to configure. So basically, this follows the approach of fire and forget. And you have no special central server. You can push the configuration from any server to any server as long as your original server from which you are pushing has the configuration stored there. So now let's have finally a look on SaltStack. SaltStack was created by Thomas Hatch in 2011 and is based on Python as well. So you might wonder, why the name SaltStack or Salt? One reason might be that the company then was situated in Salt Lake City. The other legend says that Thomas Hatch actually was watching Lord of the Rings. And then the dwarves were preparing some food, having some salted spice, salted pork. And apparently then the line fell that everything is better with salt. So thought Thomas Hatch, server-wise. So everything is better with salt. So he named his tool Salt. Salt is a hybrid compared to Puppet and Ansible. This means you can run it in two different states. You can run it as a server-client system. So it means you have a central server, salt master, where configurations are stored. So in general, these are salt states and salt formulas. And on your clients, there is a salt minion running, which can be configured to regularly inquire the configuration from the central server. So idempotence means if salt minion is already configured, everything is fine, won't do anything. Otherwise, it will change and adjust the configuration according to the salt master. But there's also a second possibility. You also can push your salt states via SSH to your servers. So you can run it in both modes, a mode similar to Puppet and a mode similar to Ansible. But on top of that, you can also use a so-called event-driven approach on SaltStack. It means you can configure the event bus on SaltStack to monitor so-called configured events. For example, you can tell SaltStack to check the disk space, and once a certain disk quota has been exceeded, for example, to just extend the hard disk. And with this configuration, you can tell actually SaltStack to fix the configuration outside a normal periodical scheduled salt run. So you won't have to wait until the salt minion normally inquires. Once the event is met, it will be fixed immediately. So SaltStack Incorporated used to be an independent company, no longer is, has been sold to VMware in 2020, and now is part of VMware vRealize. So in case you need SaltStack support, you need to buy a subscription with VMware, but there is no specific subscription to SaltStack. You will have to buy a subscription for vRealize, and this basically has divided the SaltStack community. So there was one, now there are two communities. Besides of being used as an independent tool, SaltStack is also part of different projects. So one project is Uyuni. So for those of you who don't know Uyuni is a clone of Spacewalk, which basically is basically the base of SUSE Manager. With that, you can do the lifecycle management of servers. You can deploy servers, run config management, and release management. And SaltStack there is actually the default config management tool. And to see how integral as a part SaltStack is to Uyuni, what does Uyuni mean? Actually, Uyuni is the name of the world's largest salt flat situated in Bolivia. So you see that salt actually is very important there. But there are also different projects, for example, the Foreman, which is another project than the Spacewalk, but basically has the same idea to do the lifecycle management. And Ocarino is the product from us, is one downstream project from Foreman, and their SaltStack is supported as config management tool as well. So now let's have a look on some terminology of SaltStack. So for those of you who are familiar with Puppet and Ansible, I made a comparison. So these terms are more or less match each other. It's not strictly one-to-one relation because they are slightly different sometimes because SaltStack, Puppet, and Ansible follow different philosophies and different concepts. So the most basic concept in SaltStack are so-called grains. So you can see that Salt tries to refer to terms of salt on many levels. Grains are the most basic information. So for example, the operating system, which is running on your client server, and so on. So basically this corresponds to what in Puppet and Ansible are called facts. Then the next level would be modules. The modules actually are the part which are written in the language I referred. So in SaltStack, the modules are written in Python. And actually, this is the part where clients are told how to achieve states. So basically, it tells you how to install a package, how to create a file, and so on. Then you can start combining your modules and forming a state. A state basically does what it says, what it is. So the state defines actually the state your server is supposed to be in. And then actually you can combine state and to change and make your configuration more readable by creating formulas consisting of states. Then assigning your state and formulas to servers you do with the so-called top SLS. So there you can just assign different environments and you can actually tell the server which states with which formulas and which configurations should be applied to the service. In the end, you can also provide some information, variables, and so on. In SaltStack, you do that by the so-called pillar, which in Puppet corresponds to the hira or hira data, and in Ansible to the inventory. So in the last line, then you can see actually where you can get already predefined states and formulas. So you can, if you want to create some configuration for your server, you don't have to write everything by yourself and do it by scratch. There are some community formulas where you can download them. So in case of SaltStack, for example, you can just go to GitHub and look at the project salt formulas, and then you already can just clone existing formulas and adjust them to the purpose as you need them. So now, having talked quite a bit about theory and history of SaltStack and config management, so let's get a bit more practical. If you want to install SaltStack, this is quite easy. You can just go to this URL here, https repo saltstack project.io, and install the repository, and then just install Salt on your machine. So in case of a Salt master, it's just a yum apt-get zipper. So you have the package manager, install Salt master, and the same for installing your Salt minion. So once you have done that, you have to tell your minion how to communicate with Salt master in case you run it like that. So in that case, you just go on the client server and you edit your etc salt minion, or your if you want to put it in a separate file, you can also edit the etc salt minion d minion conf and define the salt master. And when running it like that, you have to make sure that on the salt master firewall ports 4505 and 4506 are accessible so that the communication works. So much for theory. Now, the big advantage of SaltStack that it's quite beginner friendly, so it's very easy to start setting up a very simple basic system. So now the idea was just to do that. So we prepared some servers where we can install a Salt master and some Salt minions, and we will just start setting up a small system and see how we can dip our toe in and see how we can use SaltStack for configuring your server. So now I will change my share. And we will have a look on our prepared machine. So here now we prepared a machine to install actually a Salt master. So let's log in onto the machine. So we are here. You can see SaltStack is not installed yet. So let's do that. So let's install the Salt master. And on the other side, we have 3 machines prepared to run Salt minions on different operating systems. So here we have CentOS server, an Ubuntu server, and a Slash server. So let's install the Salt minion there. Let's start with the Slash server because this is, by experience, the slowest one. Putting in install might be advantage. Install Salt minion on the CentOS server. And we install a Salt minion on the Ubuntu server. So here installing. Now let's have a look on our Salt master, how it's looking like. So looking good. Let's see if our Salt master already is running. So systemctl status Salt master. Everything looks fine. It's just complaining that you have no minions yet, but this is something we are going to change. So let's go back here to our client service. So seems to be fine. We just clear the screen to see a bit more. And we okay, now the first thing we have to make sure is that our minions actually can talk to our Salt master. So now it means we configure the Salt master and Salt minion. For that, we just edit the etc salt min. You could do the minion. In our case, we want to create a separate file, so we create a minion d and minion.conf. We just define our master, which in our case was the Salt master demo ATIX, save, and restart the sort minion. Oh, restarted. So now the sort minion sent a sort key to the sort master and will ask it to be signed or accepted. So how do we check that the key arrived here? For that, there is a command sort minus key. And to list them all, we just provide the flag minus capital L. So you can see here we have accepted, denied, unaccepted, rejected keys, but apparently we didn't get anything. So what did we forget? Yeah, you remember? I told you we need to make sure that certain firewall ports are open. And actually in our system, we are running a firewall D. So let's open the port. So let's do a firewall CMD, minus permanent, minus zone equals public, minus add minus port equal port 4505 / TCP 4506 / TCP. Let's reload the firewall. And just to be sure, let's also restart sort services. So CCML restart master. And let's also restart our sort minions. Now let's actually check again. And here we go. We have 3 unaccepted keys. So let's accept them. To do so, we just do a sort key, and we can accept one key with the flag minus small a and providing the name. It will then ask us if we want to accept it. We do. In our check, we see we got 1 accepted and 2 unaccepted keys. Of course, if you have many servers, you want to do everything one by one. So in case you want to accept just everything, you can provide a capital A as a flag. And now it's asking us to do so, has been accepted. We list our keys and everything is fine. So now let's check if communication between our master and our client is working. So to do so, we just can send a salt command and to all of the servers, for example, and do a test ping. So we wait a few seconds. So yellow is quite hard to read. Let's change the contrast. So you see we got back a true. So all the servers are responding. To just check one server, you could also just provide one single name. So let's get some information about our servers. Suppose we want to know which sort minion version is running on our service. We can just do, for example, a test version. So we send that to our client, and we see the Ubuntu server is running at 3004.1. We send to a server at 3004.2, and our slash 3004 plain. So let's have a look on how the disk space might look like. So to do so, we can just do a disk usage. So you see here, you get back layout and how everything looks like. So splendid. So there are many options which we can't all see or have a look at. But in case you're interested and want to try yourself, you can just do a sysdoc to get documentation. And here actually you get a list of all the options you can actually send to your service. So you see here there are many options. So let's do a last try again. For example, now let's read. Actually, we want to find something specific out of our service. So, for example, we want to run a doc command. So to run a command on our server, we can just use the command resource cmd. So we want to run something. Let's, for example, figure out the content of our root home directory. So you can see here, we get back what's on there. Our Ubuntu host has 1 file, our slash has 2 files, and our CentOS server has 5 files. So far, so good. So let's do something more useful. So suppose we want to install some package on all our servers. So we can do the same again. In that case, we're again running our salt run, and we use a package resource, pkg, and we want to install a package, for example, screen. So we wait a few seconds, that screen is being installed. So apparently slash and CentOS didn't do anything. Probably screen already was installed, and our Ubuntu server has installed screen. So let's cross-check on our servers. Let's clear again to see a bit more. We execute screen, and here we go. Splendid. In case we want a package to have removed, it's as easy as it was to install. We just do a pkg remove, and we are good. So let's try to get some specific information of our servers. So you remember the most basic information we got were the so-called grains. So first of all, it would be nice to know what kind of grains are available at all. To do so, we can actually just do here a grains less. And now we can see actually which grains exist and with which we can refer. CC starts here. So many options, BIOS version, operating system, and so on. So let's do something using a grain and addressing, for example, the operating system version. Let's see what options we have there. So what keys could we have? So now we saw the keys, we want to see the values. So in case we want to know what actually are the grains on our servers, we can do a grains items. And then we won't only see what grains are available, but we also will see what the actual values on our servers are. So now let's just address one of these grains. To do so, we can again just do a salt. And as we want to use a grain as a filter, we provide a -G. And we just want to do it for all servers running on CentOS. And we do a test version again. So as expected, only our CentOS server responded, having a short minion version of 3004.2. Let's do a cross-check running towards our Azure server. And here now we got a 3004 plain. So the same now we can do actually installing a package just on our CentOS server. So let's reinstall screen, package install screen. And we'll see it will only install it on our CentOS server, but not on our Ubuntu and not on the SUSE server. So let's wait a few seconds. So basically, now what we've seen was the first teaser. It was nice. Actually, we could do something with Salt. But of course, that's not really automation yet, because we just pushed the commands on the shell. To automate, we need to write down all the configuration on the server and actually make it possible to be applied. So the standard path where your state and so on are on your salt master is the srv salt. So let's create this directory. So let's create the srv salt and move there. So let's write our first state. For example, we want to install a package. So let's create a state file. Let's call it package SLS because it's a package. The name doesn't matter. You could call it anyways anything. I'm just using package to make it recognizable. Then we need a unique identifier for the resource. So let's install screen, for example. Now, actually, we refer to the module. We want a package to be installed. So we define the state, package installed. We need to provide the name of the package, screen, and here we go. So we have our first state file. And now actually we want to apply it to our service. So how do we do that? As before, we can do a salt run towards our service. And in this case, we do a so-called state apply. And we want to apply our package SLS. So we wait a few seconds. So you see here, center is already done. We installed the screen right before. And so nothing need to be done. Installed on Ubuntu. Now we are waiting for the SUSE server to finish. SUSE is a bit slower. So when we have actually installed this package, the next step we will do something similar, easy. It's just creating and managing a file. So let's wait. What's going on with SUSE? Apparently the SUSE server is a bit slow. No, now it's done. So let's create and manage a file. So we will call it file SLS. And we want to do is create and manage a file. So our module is file, and we want it to be managed. So what we need to provide is a name, which means the path in this case. So let's create a file in the root home directory and call it test file 1. And it would be also nice to specify some content. So this is our first test file. A second line. That was pretty hard, wasn't it? So let's check. Looks fine. Now let's actually apply our file state and check. So we see here has been created on all 3 servers. We can cross-check here as well. So we do a cat on our test file, and content is correct. So what happens if we rerun it? Remember idempotence. It should not do anything. So it says, all right, it's in correct state and didn't do anything. So this wasn't that hard, was it? So let's change actually the content and see what happens then. So as it was pretty easy, let's change line to pretty easy and reapply it again. So you can see here, the line has been adjusted. So pretty hard was removed, pretty easy was added. So SaltStack is telling you actually what it does. And if we now cross-check here, we see the line has been adjusted. So let's do a last final check, which you can do. For example, we can also create a user. Let's create a user. Let's create a user SLS. Our identifier, create test user. Provide a name. So first we want the user to be present. We need a name for the user. Let's call the user test user 1. We can provide a full name, for example. Let's call him John Doe. Some login shell would be nice. In bash, and the home directory would be of advantage. So let's put it to home test user 1. And we save, and we apply our user state. So user has been created. Let's check the user. So let's only check on one machine. It makes it easy because you have seen that it works on all of them. So let's increase the size of this window here. So we can just grab for test user and our etc pass wd. And here our user is. And if we go to test user directory, see everything is fine. So now we want to remove our user. So we just edit our file right here. Let's remove the creation part. So let's call it destroy user. We want the user to be absent. Provide the name, test user 1. Apply the state. So user is gone. So if we grab for the user, it's no longer there. If we should try to go home directory, it's not there. But however, if we look here, home directory is still there. It's just not, just the user is gone. So it didn't clean up. In case you want to clean up, there's an additional function you need to do. So let's recreate the user and clean it up properly. So we recreate the user. We remove this part, reapply that. The user has been recreated, and now you can properly clean it up. In case you want to clean up, you remove the user and remove everything and clean it properly up, you can provide the option purge. So let's put purge to true. Apply that. And now we can just check, and home directory is gone as well. So now we created very few separate state files. Of course, you don't have to do it everything one by one. So let's just create a combined one as a cross check. So let's clear here so we can see a bit more. So let's create a combined state, combined one. So for example, we want to install htop. So this means we want package installed htop. Then we want to create test file. But here I have to provide the name, of course, otherwise SaltStack will complain. So we want a file to be managed. So we provide a name. Let's call it root htop test so we recognize things working. Provide some contents. Htop test content. And we want to create a user. Create htop test user. So user present name htop test shell in bash home htop test. So let's have a fun look that everything is properly defined. So now we can save our combined as well as. So let's just apply it to our first server. So let's use the SaltStack S7 demo addix, and we want to apply actually our combined one. So let's wait a second. htop is being installed, file is being created, user is being created, and then we can cross check. So maybe we kind of look if something already happened right here. Root home. htop test already is here. So we can see we have our htop test content. Yeah, everything ran through. CSC was successful. We go now to the home directory of our htop user, everything there, and the package htop is running as well. So of course, if you put all your modules only in one state, if you have a more complex state you need to define. It might be favorable to distribute it over several files and create a structure which is better to understand. This would be a so-called sort formula. So we can try to do that now. So let's just create a combined 2. So we have here a directory, and if we have the sort formula, everything starts with the init SLS. But let's first have a look on our modules. So let's just have a look here on our combined 1, and let's split it in several parts. So this was our package SLS. So let's create a package SLS. A file SLS. And the user SLS. So how actually do we apply that? How do we solve it? So SLS goes to say everything starts with an init ls. So if you apply a formula, it will always look in init ls first. So we need to create an init SLS. And now we just do an include. So we want to include the package SLS, file SLS, and the user SLS. So now we go up. We now actually apply our combined 2. And you see, it basically did the same. So you can see that everything already specified and idempotent, so our state was fine. So you see both approaches are the same, exchangeable, so this looks fine. So now let's have a look on a more realistic state file. So here we have prepared a sketch for an Apache SLS. So this one will be functional because it's just a sketch and there are some things missing, but it's enough to first understand the concept. Let's open our Apache SLS. We can see here we have one identifier called Apache, and apparently this name can be used for several things. So you see we install a package, we ensure that the service is running, a user and a group is present, and all of them are referring to the name Apache. So what does the state do? So first of all, it's installing the package Apache. Then it's making sure that the service Apache service is running, and it's watching other modules. So I will explain the watch in a few seconds. Let's just continue with this part. Here it's creating a user called Apache with given user ID, group ID, home without shell login, and it has a require on the group Apache. So here we have the group present, creating the group Apache with group ID and itself requiring Apache package. So this require means that this resource needs to run after that one. So the user is to be created only after the group has been created because the group is required by the user. The same applies to the group. So the group only can be created after the package has been installed. So actually it is going to run this way, installing the package, making sure we're creating the group, creating the user. Then here on the bottom, we have the file managed, the htdconf, which in this case is copied from a file or it can be from a template. So here it can be provided as a template or a file resource, and you define user, group, and mode. And then from this, your config will be created. Now moving back to our watch. So we can see here it's watching actually the package Apache, the file htdconf, and the user. This all refers to the service. And it's having a look if the Apache package changes, the config file changes, or something changes in the Apache user. In case of one of these things here change, the service will be notified and it will be restarted so that Apache is always running in the configuration mode it is intended to. So far for the sketch. Now let's have a look on a real Apache state and see how it looks like. So we also have to create that. So let's move back to our SRV salt. And let's copy state we already prepared for that. Let's put it here. So let's go here to Apache. And here you can see how such a formula can look like. So as I said in the formula, everything starts with the init SLS. So let's have a look on the init SLS. So you see it's quite easy at the beginning. It's just including package, config, and service. And here, based on some grains, we are actually defining a file. So the index line of Apache. So in case of Red Hat and Debian, we index HTML is located in var www.html. In the case of SUSE, it's just in server www.ht docs. So now we can also provide certain grains. You can see here we have different YAML files, one pointing to the OS map, OS family map. Let's have a look on random as well. So let's have a look on the OS map. So you can see here we have nothing special for Debian-based families, but here for Red Hat, for example, we are defining some package and some package dependencies. So here we are defining some grains so that Apache later on knows when we are running the formula or state on a Red Hat-based server, these are the packages which are required. Having a look on the OS family map, actually we can see here now, we also get this value for Debian-based, because in this case for Ubuntu and for Debian, it's not a difference. They have been the same. So you can see here the name of the package for Debian-based system is Apache 2. The service is called Apache 2. The user is www-data. In contrast to that, we provided for Red Hat. In case of Red Hat, things are called not Apache 2, but HTTPD. And moving on to SUSE, again, the name will be Apache 2, but the name of the user will be www run. So now we've seen that our init SLS was calling the package, the config, and the resource. So let's move on to package. Here again, everything starts with the init SLS. So we see here we are only including install. Now looking at install, we can see here actually we are installing the required packages and dependencies as they have been defined in the YAML files we saw before, based on the operating system or operating system family. Also creating the group and the user, which are required for Apache. Next, we got to our config, which again is a formula. So we look at init again. So we see here we have several resources here, starting with file, flags, log rotate, and creating the configuration. Let's have a short look at our file SLS. So we can see here we're including additional states, making sure that the required file directories for our configuration are created, and creating all the configuration files which are required for Apache to run. Last but not least, we come to the service. And now you can have a look here in it ls again. And not surprisingly, it's also as simple as before. We just are including the running SLS. And now actually we can see here, it's including again some config files and making sure the service is running, watching config files, and executing everything we need to for the service to be running. So you can see here, you can map quite complicated scenarios with SaltStack and make sure that all the files, all the services are correctly configured and then actually running. So now the last test, we want just to apply this formula and actually want to assign it to a server in a proper way. So we will just start creating a top SLS to assign that to our file. So we will just create a top SLS. We need to define our environment our server lives in. We can now define the servers which are supposed to be in this environment. And then we just add our state or our formulas. So now, how do we actually apply that? So it's quite similar as before and quite simple. So we just do a sort star. And now in this case, actually, what we do was not a state apply, but we want to do a state iState. And we have to specify the salt environment. we require, which would be base, and we run it. So this is going to take something like a minute or so, or two. So in the meanwhile, let's have a look on our client service, because I told you can configure your minions to regularly run and inquire their configuration. So we'll do that right now. So let's move back to, well, we can just do it for one, doesn't matter. So in that case, we just go here back to our etc, salt minion d. You remember we defined it in the minion conf. So actually, so what we want to do is a schedule. So let's add a schedule. We are talking about high states. So we add a high state. We define the function which is supposed to be executed. That is state high state, as you have seen. State, high state, not high date. And then we just give a schedule. So for example, let's say we want to check it every hour. So we just say 60 minutes. Save that. We restart the sort minion, and then it will start inquiring its configuration every hour. I won't do it right now because we are running a sort state at the moment and it might interrupt the case. But you can see here, the first one is already working. So we can see here that, okay, all of them work. So we already ran through. So now let's have actually a look on what we got. So I will create a new tab and change the share again. So let's have a look on this here. So let's see what we got on our server. So we got here now our SaltCenter S7 demo ATEX. And here we get our message. Let's zoom in a bit. The same for our HTTP Ubuntu 20. And last but not least, also our S15. So, worked fine. Looks great. So let's do a final thing which can do, let's make use of some granular method, because now we applied the same message to all our servers. So let's change it again. So let's adapt something. Moving back to our sort master. So what we can actually see here, if we go back to our Apache formula, if we go back here to the init SLS, we can see here the file which was used was this Apache, this index.html Ginger. So let's see where this file is. It's here in files. And if we go now here to index.html Ginger, we can actually see what it actually applies. So let's just add something. So let's take the Ginger breaks. And first let's use some grains. So grains, and use the OS. And we save. We go up here. We reapply the salt state. So it's not supposed to change too much. It's just changing a message. So you can see here, removing the old line, adding the new line. So let's see that the last one runs through as well. And then let's have a look on our browser again. Where's the browser? Here's the browser. So let's refresh. So we got our CentOS server. So welcome on CentOS. Welcome to Ubuntu. Welcome to SUSE. So you see, it's quite easy to start using SaltStack, and it's you have many options to actually configure your service. So I hope you enjoyed this webinar. If you have any questions, just feel free to ask them. We have a chat function here. I will wait for something like a minute. And yeah, so let's see if someone is still having questions or interested. So no questions yet. So everything seems to be clear and fine. So as I said, I hope you enjoyed the webinar, and thank you for your participation. Bye.